The Mind Museum is a science museum located in Bonifacio Global City, BGC, Taguig, Metro Manila, on a 1.2-hectare lot in JY Campos Park. The ticket rates at the Mind Museum are P625 for adults, P550 for children and private school students, and P30 for public school students, teachers, and their companions for a 3-hour visit, while an all-day pass costs $750 for both adults and children, with discounts available for senior citizens and PWDs. The Mind Museum is open from Tuesday to Sunday, 9 a.m. to 6 p.m., and is closed on Mondays. The Mind Museum features over 250 interactive exhibits spread across 5 main interconnected galleries, each focusing on a specific theme. These galleries are designed to make science engaging and easy to understand through hands-on activities, models, and immersive displays. Visitors can explore different scientific concepts as they move through the museum, allowing them to learn at their own pace in a fun and interactive environment. The Pearl of the Orient Gallery is one of the featured areas inside the Mind Museum that highlights the rich natural and cultural heritage of the Philippines. It showcases exhibits that focus on the country's unique biodiversity, geological features, and cultural identity. Through interactive displays and informative panels, visitors can learn about the Philippines as part of the Ring of Fire, its diverse ecosystems, and the ways in which its natural environment has shaped Filipino life and history. This gallery aims to foster national pride and awareness of the country's natural treasures, while encouraging visitors to take part in protecting and preserving them. The Universe Gallery at the Mind Museum takes visitors on an exciting journey through space and time. It explores the vastness of the cosmos, from the origins of the universe in the Big Bang to the formation of galaxies, stars, and planets. The gallery features stunning displays, interactive models, and immersive exhibits that explain complex astronomical concepts in a way that's easy to understand. Visitors can learn about celestial bodies, space exploration, and humanity's place in the universe, inspiring curiosity about what lies beyond our planet. This gallery creates a sense of wonder and awe, encouraging people to look up and imagine the infinite possibilities of space. The Earth Gallery at the Mind Museum focuses on the dynamic forces that shape our planet and its natural wonders. It features exhibits that explain geological processes such as earthquakes, volcanic eruptions, plate tectonics, and the rock cycle. Visitors can explore how mountains, oceans, and landforms were formed over millions of years, and how these forces continue to transform the Earth today. One of the most popular attractions at the Mind Museum is the Tyrannosaurus Rex, T-Rex skeleton displayed in the Earth Gallery. The T-Rex skeleton is not just for display. It's accompanied by educational panels and interactive features that explain the dinosaur's characteristics, behavior, and the science behind fossil discoveries. The gallery also highlights the planet's rich natural history, including fossils and evidence of past life, giving visitors a deeper understanding of Earth's evolution. Through interactive displays and engaging visuals, the Earth Gallery inspires appreciation for the planet's power, beauty, and ongoing changes. The Atom Gallery at the Mind Museum focuses on the microscopic world and the fundamental building blocks of matter. It explores atoms, molecules, forces, and particles through interactive exhibits and visually engaging displays. Visitors can learn how everything around us is made up of tiny particles that follow the laws of physics and chemistry. The gallery introduces concepts like atomic structure, chemical reactions, and states of matter in a fun and understandable way, making it ideal for students and science enthusiasts. By zooming in on the invisible world, the Atom Gallery helps visitors appreciate the science that operates at the smallest scales to create everything we see and experience.
Here sa Atom Gallery, may tinatawag kaming mind-moving studios. Kung nasaan kayo nakaupo ngayon. Ito po yung mind-moving studios kung saan nag-experiments po kami para sa inyong lahat. Alright? Okay, before we start, let's try to relax muna. Okay, relax muna tayo bago mag-ikot. Okay? So let's try to inhale, exhale first. Okay, mag-breathing exercise muna tayo, right? 1, 2, 3, inhale. Exhale. Okay, last one. Let's try again. Inhale. Exhale. Anong tawag sa gas na ini-inhale natin?
Oxygen!
Oxygen, perfect. Or O2, right? Okay, oxygen or O2. How about yung gas na ina-exhale natin. Ano tawag doon?
Carbon dioxide.
Carbon dioxide gas. Perfect. Thank you. Alright? Anong chemical name ng carbon dioxide gas?
CO2.
CO2. Okay. So actually, ang topic po natin ngayong umaga, pag-uusapan natin yung properties na meron sa gas na ina-exhale natin, which is carbon dioxide gas. Okay? So maraming properties po yung carbon dioxide gas na bakit kaya siya special? Okay, let's see. Yung first experiment natin, tutulungan ako ni Kurt. Actually, yung first experiment natin, gagamit tayo ng fire. So, going to use fire. Meron kami 4 candles here. And then, ngayon na binubuksan niya yung ating candles, gagamit kami ng beaker, itong container natin, because magmi-mix tayo ng dalawang common household items. Okay? Magmi-mix tayo ng dalawang to. Meron kaming baking soda dito at saka vinegar. Kung familiar kayo sa baking no experiment, no? Ito yung ginagamit, baking soda and vinegar. Okay, sige, let's try. Maglalagay tayo ng scoops ng baking soda here sa ating container. I think 2. Ayan, I think 2 scoops, no? Alright, let's try. Let's mix yung ating vinegar sa baking soda. So if we mix these two, as you can see, we form a lot of bubbles, right? Okay. Ayan, so meron tayong bubbles inside, and then si Kurt, ititilt niya yung beaker sa ating fire. And tingnan niyo kung anong nangyayari sa fire. Okay, for our third and last candle, let's see. Okay, anong nakita niyo? Anong nangyari sa candles? Namatay yung candles, pero bakit kaya siya namatay? Kinatapon ba si Kurt ng vinegar? Hindi, tama. Wala siyang natapon. Pero bakit kaya namatay yung apoy?
Kasi yung carbon dioxide and yung water, at when you mix it together, it will like patay the fire if you like patay the fire of the air.
Okay, tama naman yun. At palapakan naman natin ang ating okay, over here. Tama naman yun. Okay, that's because of carbon dioxide gas. So, paano tayo nakapag-create? Paano tayo nakagawa ng carbon dioxide here? So, nung nag-mix ng dalawa, si Kurt na to, baking soda and vinegar, nung nag-mix tayo dito sa beaker natin, sobrang daming bubbles sa loob ng beaker natin. And sa loob ng bubbles na yon, ito po yun, carbon dioxide gas. Okay? And sabi ko kanina, maraming properties yung CO2. Isa na doon, yung tinatawag na, ang CO2 po ay isa siyang dense gas. Okay? Isa siyang mabigat na gas, yung ina-exhale natin, dense gas yan. Okay? Since mabigat siyang gas, yung CO2 namin dito, actually, nag-stay lang siya dito sa loob ng beaker namin. Nag-stay siya dyan at some point, no? Hindi nyo nakita na dito yung CO2 namin. That's because gas po siya, invisible gas po siya. And, since nandito sa loob yung CO2 namin, so, nung pinilt ni Kurt yung beaker natin dito sa ating candles, lumabas yung carbon dioxide gas at pinatay niya yung apoy. Ngayon po, paano naman po pinatay ng CO2 yung apoy? Okay, gas siya, hindi pa siya, water. Right? Paano na pinatay ng CO2 yung apoy? Ang fire po kasi, or yung apoy, kailangan niya ng oxygen para mabuhay. O2. Tayong mga tao, kailangan din natin ng oxygen para mabuhay. Ganun din po yung fire. Kailangan niya ng oxygen para mabuhay. Since ang CO2 ay mabigat siya, mas mabigat po siya compared sa O2. Okay, again, mabigat yung CO2 compared sa O2. Why po? CO2, meron siyang extra carbon atom. CO2, O2. Ang ginawa ng CO2 here, na-remove na po yung oxygen supply na meron sa fire. Ibig sabihin, sinofocate na po yung fire, tinanggalan niya ng oxygen supply, kaya po namatay yung fire. Ito pong experiment na to, actually, similar siya sa mga fire extinguishers. Kung paano po gumagana yung fire extinguishers. Why po? Because yung mga ibang fire extinguishers po, meron silang CO2 or carbon dioxide gas. Hindi po lahat ng fire extinguishers ay water yung loob. Yung iba naman po ay gas, which is carbon dioxide gas. Because again, ang property ng carbon dioxide gas, mabigat siyang gas at kaya niyang isuffocate yung apoy. Okay? So yun po yung ating first experiment about CO2. Kaya niyang patayin yung apoy because dense gas siya. Okay? So let's try another application of carbon dioxide gas. Actually, gagamit po kami ng water. Water lang po ito na nilagay namin kanina. And then, gagamit po tayo ng chemical. We have a chemical here. This chemical po is what we call phenolphthalein. Phenolphthalein. Familiar po kayo sa phenolphthalein? Okay, ito po yung spelling nun. Medyo mahabang word po yung phenolphthalein. Okay? Ayan. That chemical po is what we call phenolphthalein. And phenolphthalein po is also known as pH indicator. Isa siyang indicator. Okay? pH indicator. Okay? So, ano yung ini-indicate niya kung isa siyang indicator? Ang ini-indicate niya kung ang isang substance ba ay acidic or basic. Again, acid-base indicator ang phenolphthalein. Okay? So, kapag naglagay tayo ng phenolphthalein sa acids, no, and bases, magbabago yung solution na yun. Now, since acid-base indicator ang phenolphthalein, can you give me examples po ng acidic substance, mga acidic na alam niyo? Vinegar. Vinegar, tama po. Vinegar, gumamit kami kanina, is also known as acetic acid. Acid po ito. Ano pa po? Usually po, common acids ay mga maasim. Ano po yung mga maasim na alam niyo? Ayan, hindi naman po yung iniisip natin, no? Hindi yan. Okay, ano pa? Pawis. Okay, makapag na-taste nyo, maasim. Ano pa po? Bukod po sa suka, ano ba yung mga asim na alam nyo? Kapag lemon, tama po, no? Lemon, lime, calamansi, mga alam nyo, mga citrus fruits, no? Meron silang, tama, meron silang citric acid na tinatawag. At may acid yan sila, okay? And ascorbic acid or vitamin C. So kapag umiinom kayo ng vitamin C, no, maasim yung vitamin C. Now, if we add vinegar, lemon, lime, calamansi sa phenolphthalein, sa indicator natin, yung solution natin po, magiging ganito. Magiging clear siya. Lahat ng acids na ilalagay niyo sa phenolphthalein magiging clear. How about bases? Kung ang acids ay maasim, kapag lumikman niyo yung mga bases, actually mapapakla sila or bitter. Okay? Ano ba yung mga mapapakla na alam natin sa bahay? For example, baking soda, that's right. Baking soda is a type of base. Ano pa po? Okay, yung thing na pinapang-wash natin ng bodies natin, ng clothes, soap, tama po. Soap is a type of base po. Kaya lahat ng alam niyong soap ay mga bases din sila. So kapag naglagay tayo ng bases sa phenolphthalein, ano yung mangyayari sa solution natin? Let's see. Meron tayo dito, okay, sige, maglalagay muna tayo ng phenolphthalein, which is yung indicator natin. Ayan. Lalagay tayo ng phenolphthalein sa ating water. Again, water na po yan. And then, like I said po, mag-a-add tayo ng soap or base sa ating phenolphthalein. And let's see kung anong mangyayari sa ating phenolphthalein. Alright? Meron kaming soap here. This one po is what we call sodium carbonate or washing soda. Washing soda po is main ingredient siya sa mga laundry detergents or sabong panlaban. Ito po, sodium carbonate powder po siya and color white siya, okay? Yan. So, since white powder, yung sodium carbonate, kapag nilagay natin siya sa phenolphthalein, magiging ganito yung color, okay? So, lahat ng bases na ilalagay natin sa ating indicator, magiging ganyan yung color niya. Magiging pink, magiging magenta na color. O, deep pink siya. Now, guys, actually, our topic today is all about CO2, right? Carbon dioxide gas. What if maglagay tayo ng carbon dioxide here sa ating clean solution? Let's see. So, si Kurt at saka ako, maglalagay kami ng carbon dioxide gas dito sa ating clean solution at tingnan natin kung ano mangyayari. Okay? Let's see. Sige, Kurt, mag-blow lang kami ng bubbles, hindi namin siya iinom. Okay? 1, 2, 3, go! Ito natin ito siya. Ayan. As you can see guys, ano yung nawala? Nawala yung color niya, nawala, okay? So, bakit kaya nawala yung color pink? Ininom kaya namin ni Kurt? Ininom ba namin? Okay, hindi po namin ininom, wala po kami naninom. Pero, bakit yung pink natin nawala? Bakit yung color pink natin nawala? Ano kaya nangyari here? Ibig sabihin, may nilagay kami ni Kurt sa ating class. Ano kaya yun? Okay, carbon dioxide gas. Tama po. May nilagay kami carbon dioxide gas sa ating pink solution at yung pink solution natin naging clear, right? Okay. Ibig sabihin, ulit, nag-add tayo ng CO2 sa ating solution at naging clear siya. Ibig sabihin po ba, yung hininga natin, yung hininga natin lahat ay acidic siya? What do you think? Kasi, like I said earlier po, kapag mag-add tayo ng acid sa phenolphthalein, magiging clear. Nag-add tayo ng CO2 at naging clear siya. Ibig sabihin po ba, acidic yung hininga natin? Okay? Ano pang meron sa class natin bukod sa phenolphthalein at sodium carbonate? Anong meron? Bago kami naglagay ng kung ano-ano, ano yung meron sa class natin? Ano tawag sa liquid na to? Water, okay. Hindi po natin ininom yung water, nandiyan pa rin po sa class, okay? So actually, yung hininga namin ni Kurt, nag-dissolve siya sa water, okay? Nag-mix siya sa water. So kapag ang CO2 nag-dissolve sa water, o nag-mix siya sa water, makakapag-create tayo ng acid na tinatawag, okay? Nakapag-create kami ng acid. Ano tawag sa acid na yun? Ito po yun. Okay, carbonic acid. Actually po, ayan, again, kapag nag-mix yung carbon dioxide gas, hininga natin sa ating water, makakapag-create tayo ng carbonic acid na tinatawag. Actually po, carbonic acid, very familiar yun dyan, hindi lang natin alam, okay? And yung carbonic acid, present siya sa mga favorite drinks natin, lalo na sa adults. Anong tawag doon? Tama po, soft drinks or sodas, no? That's why yung sodas or soft drinks, tinatawag silang ano po? Carbonated drink, okay? Dahil may carbon dioxide po na nakahalo doon sa ating favorite drink. And to test that, para maniwala kayo sa akin na may CO2, for example, if you open a can of soda or bottle, anong naririnig nyo? Magbubukas tayo ng bottle, anong naririnig nyo? May gano'ng effect, no? May parang effect, right? Yun po yung time na lumalabas yung CO2 sa bottle or sa can ng soda. Hindi mo spirit yun, okay? Wala pong spirit doon. Carbon dioxide lang po yun na lumalabas sa bottle or sa can. Again, dahil may carbonic acid, may nakahalong CO2 sa ating sodas or soft drinks. Yun lamang po ang ating experiments about carbon dioxide gas. Again, mabigat siyang gas at kapag yung pininga natin, nag-dissolve sa water, makakapag-create tayo ng carbonic acid. Thank you everyone for joining us.
One of the key features of the Life Gallery is the exhibit on the human brain, which explains how this remarkable organ controls our body and enables us to think, feel, and create. Other sections showcase the variety of plant and animal life found in the Philippines and around the world. By combining science with engaging visuals, the Life Gallery inspires visitors to appreciate and protect the diversity of life that surrounds us. The Who We Are section at the Mind Museum explores the story of humanity, how we came to be, how we are connected, and what makes us unique as a species. It explains our origins through the lens of science, tracing the journey of humans from early life forms to modern Homo sapiens. The exhibits highlight our biological makeup, shared ancestry, and evolutionary history, showing how we are part of the larger web of life. The engineering exhibit on the second floor of the Mind Museum highlights human creativity, problem solving, and innovation through interactive and hands-on displays. This section allows visitors to explore the principles behind structures, machines, and modern technologies. Exhibits often include activities where guests can build simple structures, experiment with mechanics, or understand how everyday technologies work. It demonstrates how science and mathematics are applied to design bridges, buildings, and tools that make life easier. By engaging directly with these exhibits, visitors gain a deeper appreciation of how engineering shapes the world and encourages them to think like real engineers.
Yesterday, was it rainy or was it sunny? Yesterday. It was very rainy yesterday. And even today, right, it's a bit gloomy outside. It's not very sunny. Why is it rainy yesterday? Because there was a typhoon, right? Yeah. So when you see a typhoon on the news, what does it look like? In the weather news, did you see what it looked like? No? You don't watch the news, right? So if ever you do watch the news and you see the weather map and there's a typhoon, you will see something that kind of looks like this, right?
Yes.
Have you ever seen this before?
Yes.
No, right? I bet the adults do, right? But when there's a low pressure area, or eventually when it becomes bigger, a typhoon, you will see this on the weather map. And this is the top view of a storm, of a typhoon. But if you see it from the side, it will actually look like this one. How about this one? Does this one look familiar to you?
A tornado?
It does look like a tornado. So here in the news, you will see like this. It's called an LPA or sometimes a typhoon, right? But they all look like this one. This one is a tornado. So all of these things, tornado and typhoon, are examples of low pressure systems. LPA stands for low pressure area. So let's focus on this one, tornadoes. Do tornadoes move fast or do they move slow?
Slow.
They move fast, right? They move really, really fast. It's fast moving air. And what does it do to objects near it? What does a tornado do to objects near it? Does it push objects away or pull? Pull, right? So let's say there's a tree nearby. There's a big chance that the tornado can pull it, right? Because tornadoes are really fast and they're really, really strong, right? So why did we talk about tornadoes and typhoons and low pressure areas, right? Because for the first experiment, we're gonna simulate how typhoons, low pressure areas, and tornadoes move. And we're going to see what's going to happen if we copy their movement. So I have here a few feathers, right? And I'm gonna show you that when I copy the movement of a tornado or a typhoon or a low pressure area, I can make these feathers float upward. So right. So how does a tornado move? If you want to copy the movement of a tornado, how does it move?
Spinning.
It's spinning, right? Does it look like this one? Yes? Okay, so it's spinning, right? So we're gonna copy that movement and we're gonna see if it's gonna make the feathers float, right? So it doesn't really do anything. It just moves the feathers around. It can't pull the feathers upwards. So this is not an accurate representation of the movement of a tornado. Tornadoes move more like this, right? What's the difference? The circle is bigger at the top and the circle at the bottom is smaller, right? It looks like a cone, right? An ice cream cone. That shape is an ice cream cone, right? So let's do that and let's see what happens. If I put it here, you see that the feathers get pulled upward. So this is already our mini tornado, right? It moves like a tornado and it's able to pull objects, right? It's able to pull objects to the top, right? Pull objects and bring it up, right? So let's take a closer look how that works, right? This is again the movement of our fake tornado. So where is the movement bigger? At the top or at the bottom? At the top, right? Because the movement is bigger at the top, where is the air moving faster? At the top or at the bottom? At the top, that's right. Because right, they do the same number of rotations, but this one covers more distance. That's why, yeah, the movement of the air at the top is faster. So when there's fast moving air, you create low air pressure, right? Yeah, so low air pressure is formed when there is fast moving air. That's why low pressure areas, typhoons, and even tornadoes, all of these examples are fast moving air and they all create low pressure. That's why they're called low pressure systems, right? So that's how tornadoes or storms are formed, right? When there's fast moving air that is spinning around, it creates low air pressure. And when there's low air pressure, it tends to pull objects towards itself. So if there's a low pressure area, it will pull all the clouds, all the moisture until it grows bigger and bigger, and that's how you basically form typhoons or even super typhoons, right? So what happens when there's a typhoon again? When there's a typhoon, there is what happens? Exactly, right? But what happens in the real world? When there's a typhoon, there is rain. Where does rain come from? From the clouds. And that's what our next experiment is going to be about. How clouds are formed. So Kuya Ralph will do the next experiment. We have here a bottle filled with alcohol. This alcohol is the same alcohol you use to clean your hands, but this one is just with purple food color to make it more visible, right? So right now, okay, let's remove the cap. Right now, nothing is covering the bottle, correct? And it's not filled to the very top. Do you think it's going to be easy or difficult to squeeze the bottle? Difficult, easy, right? This one is just made up of plastic, so as you can see, it's very easy to squeeze the bottle. Again, because nothing is covering it and it's not filled to the very top, right? But if we cover it with this one, and we add 1 pump of air. We're gonna add 1 pump of air. How about this time? Will it still be easy to squeeze the bottle? No, right? Yeah, so as you can see, it's way harder to squeeze the bottle. Why? Because of air pressure. That's right. We added air inside the bottle, which means that the pressure inside is high, right? So that we add more air, we increase the air pressure. What do you think? Will it be high energy or low energy? High energy, that's right. Because there are lots of air stuck inside a small space, right? So if the energy is high, will it be hot or cold?
Cold.
I know, right? It's kind of confusing. And some people tend to think that it's going to be cold because there is more air, right? But that is only true when you're outside. When you're walking outside, there's a lot of air, mahangin, malamig, diba? But this one is a closed system, right? Or a closed container. It's a closed container, right? So all of the air gets trapped inside, the pressure increases, the energy becomes high, and when there is a lot of energy, it actually becomes hot. Just like when you're inside a room where there's a lot of people. When there's a lot of people inside a room, is it cold or warm? It's hot. It's hot, right? Or it's also warm because there's a lot of energy. The same is true for air molecules. So what happens to liquids when it is hot? They evaporate, right? Sometimes they boil first, but eventually they evaporate. Do you know what evaporation is? Evaporation is when liquids turn into gas, right? So right now, because of the high pressure and the high temperature, some of the alcohol is actually evaporating or turning into gas. So let's add 1 last pump of air. Muna po, no? Ayan, hindi na kaya. So the pressure is really high, the energy is really high, it's kind of hot inside the bottle, and evaporation happens. Remember that. Okay, so we're going to remove the stopper and see what's going to happen to the pressure, temperature, and the process inside. So this is going to make a bit of a loud sound. So if you don't like loud sounds, you can cover your ears before we let this go. Okay, we warned everyone already, right? So in 1, 2, 3. Alright, what do we form inside the bottle? What does it look like? It looks like a cloud, right? Is it a solid, a liquid, or a gas? I love the confidence. So let's take a closer look if it's really a gas, right? Let's do the experiment one more time. Remember, when we add air, we increase the... When we add air, we increase the pressure and we also make it hot, and alcohol evaporates and turns into a gas, right? When alcohol turns to gas, can you see the gas?
Yes.
Do you see the gas right now?
No.
No, right? When alcohol turns into a gas, it's invisible. It's colorless. So when alcohol is a gas, remember you're not supposed to see anything. Now we will remove the stopper again. Cover your ears. 1, 2, 3. Alright, so when we remove the stopper, what happens to the pressure? From high pressure, it becomes low pressure. From high temperature, from hot, it becomes colder. What is the opposite of evaporation? Condensation. Because it is colder, all the alcohol that turned into gas, all the alcohol that evaporated, turns back into liquid. So this cloud that you see over here is actually not made up of gas. It's made up of liquid, but in the form of tiny, many tiny liquid droplets. So the clouds that you see in the sky are also not made up of gases. They're made up of tiny liquid droplets and maybe a little bit of ice crystal. So this is actually more, this one is called a mist, right? When you spray alcohol on your hands, right? It creates a mist that looks like a gas, but you know that it is made up of liquid, made of tiny liquid droplets. Right? So how do we form clouds? So the heat from the sun evaporates the waters on the surface of the earth, and when water turns into gas, it goes up to the skies where it is colder, and that when it is cold in the skies, all the gas that evaporated will turn back into liquid, right? Will condense back into liquid. That is how you form clouds, right? So imagine if there's a typhoon, there's fast-moving air, and it pulls everything near it, right? And there's a lot of clouds. It will pull all the clouds to form one big typhoon or one big storm, right? And that is it for this time's My Moving Studios. If you have questions, you can stay. If not, enjoy the rest of your stay here at the My Moving. Thank you.
Our next song is Dream School, the theme song of My School, our very own TV show. Well, learning is never boring in My School.
The space shell is a dome-shaped structure that offers an immersive experience of outer space. Inside the space shell, visitors can watch captivating audiovisual presentations that simulate a journey through the cosmos. These shows feature topics like the Big Bang, the formation of galaxies, stars, and planets, as well as space exploration and humanity's quest to understand the universe.
We hope you have a blast. There's one. This is my lucky night. Got to see a bright one right away. Huh?
Good evening. Sorry to have startled you. Are you always looking at the stars by yourself? Don't worry, I won't tell on you. Are you conducting a meteor observation?
Do you know about this stuff?
Yes. Oh, it's starting.
Huh? What? No way!
Shooting stars.
I've never seen so many. I can't write them all down.
That's it. The door's closed. The door's closed. The door's closed.
Fascinating. It's as if it's raining stars.
It's called a meteor shower. It happens at the same time every year. But I've never seen so many appear like this.
You can make a lot of wishes.
Do you seriously believe that kind of stuff? Shooting stars are dust particles, floating in space that shine when they come hurtling toward Earth.
Really? How does the dust shine?
It lights up because of plasma.
Plasma?
Yup. The falling dust comes from that radiant point.
Radiant point? Why do you know such a term?
Come on, everyone knows. It's common knowledge.
I see. Common knowledge, is it?
I always do meteor observations here. Science is my favorite subject at school, and I know all about the stars. I'm going to be a scientist when I grow up.
You're a special young man. I once liked you.
Wait, you're a scientist?
Oh, well, no.
Oh, okay. Whatever.
By the way, do you know how high that shooting star is when it shines?
Well, it would be at a higher altitude than an airplane, so...
Let's go see where it is.
What?
Oh.
What did you do? The shooting stars are still. Wait a minute, this... Whoa! What's going on? Am I dreaming?
Oh no, we've just been released from gravitational force.
Okay, look, that's not what I meant. I'm asking, why is this happening? I mean...
Don't worry about it. About 10 kilometers up from the ground. It looks like the shooting star is shining at a higher point than this plane.
Yeah, of course. Just like I said. Wow, it's shining.
Altitude 100 kilometers. So what do you think about seeing a shooting star up close? It's about the same size as that airplane we saw.
I never knew shooting stars were this big. So yeah, this is plasma.
Oh, I see. And where is this dust you mentioned earlier?
It's inside. Okay, I said dust, but it's space dust. So there should be big rocks.
I see. Well, let's take a look then.
Wait a minute. That's weird. There it is. This tiny grain of sand. Meteors are tiny grains of sand.
I guess your calculus wasn't quite accurate. When this grain of sand collides with the atmosphere at an incredible speed, its atoms change to a state called plasma, sending it to light. The plasma spreads out, so that's why such a big ball of light is formed.
Yeah, I knew that. Sure, of course. So a meteor isn't something running up.
Oh my gosh!
Let's go higher up in the sky.
Higher up, but you're already higher up. You're already in the sky. How can they do that?
So tell me, why do you want to become a scientist? Surely it's not because you want to show off to your friends.
No, I mean, of course not. There's this person I really look up to. His name is Denson Olmsted.
Oh,
He's the one that solved the mystery about shooting stars. Well, he's a person from a while ago, but yeah.
so that's why you observe the stars.
Anyway, we're coming up to the radius point, right?
Yes, we are.
Hey, the meteors aren't spreading out in a radial pattern anymore. What's going on?
Here, let's take a look. Meteors are parallel. But if you look from a different direction, they look like they're radiating.
So this is what the radial point is. You knew, didn't you?
Just knowing about the answer won't make you a scientist. And pretending to know doesn't help either.
I'm sorry. I'm embarrassed. There's so much I don't know.
We all make mistakes in order to find our way.
Look!
The shooting stars are starting to shine.
So that means the grains of sand are zooming toward the Earth from over there?
That's right. A small grain of sand can't actually be seen, but you can probably imagine it now.
Wow, you're right. I can see it. Look, over there. Over here, too.
Take a look behind you.
Wow, awesome. There are so many meteoroids. The pieces that make meteors.
Let's speed up time a bit.
Meteors starting to move. They're gone. The shooting stars are gone.
The Earth passed through the area where the grains of sand were.
So through my meteor observations, I was checking the areas with lots of grains of sand and few grains of sand.
That's why it's important to observe meteors. Remember how you said that meteor showers occur on the same day every year?
Yeah.
All right then. So if this grain of sand is always here,
Oh, I get it. I know why meteor showers can be seen on the same day every year. It takes the Earth 1 year to revolve around the sun. That means the Earth will come to this place where the sand grain is in exactly 1 year. That's why meteor showers happen on the same day every year.
precisely. Bravo.
But why are these sand grains here in this particular place?
What do you think is the reason?
There are grains of sand on Earth too, right? So maybe they came from Earth a long time ago.
Well, now, you see, everything that exists in the solar system all revolves around the sun. That includes this grain of sand as well. It isn't stationary. It's going around the sun on its own orbit.
You mean there are grains of sand all along this orbit?
That's right.
The Earth and the sand grains have different orbital paths.
If the sand grains had come from Earth, don't you think they would follow the same path?
Oh, yeah, you're right. I got it. Okay, that means there's some astronomical object along this orbit that checks out these grains of sand.
Excellent. You've applied knowledge to think through a question and made a prediction. That's the first step to becoming a scientist.
Huh?
All right, let's go find it.
Wow, it's filled with grains of sand.
These sand grains take several decades to orbit the sun.
And they collide with Earth. Hey, what is that? Look, there it is. Yeah.
It's too early to celebrate. We must check to see if the sand grains are coming out of here.
Yeah, you're right. Hey, something's bursting out. It's grains of sand. Yes, sand grains are coming out of here.
Wonderful. It's just as you speculated.
Oh, this is a comet.
Precisely.
Comets leave a long trail behind, right?
Yes. Unlike Earth, comets are mainly composed of ice. That's why they start to melt when they pass close to the sun and release gases along with sand grains.
Shooting stars are born here.
That's right. This is the very thing that creates meteor showers. Now let's take a look at the entire solar system from farther away. There are many, many comets in the solar system. Unlike Earth, comets follow an elongated oval orbit, and some of them intersect with Earth.
Oh, those intersections are where we can see meteor showers. And that's why we can see different meteor showers throughout the year. They are born from comets, take a long time to go around the sun, collide with Earth, and at the last moment, become shooting stars. Meteor showers are part of the solar system.
You're already a fine scientist.
I wouldn't have understood anything without you, mister. Wait, you're starting to shine.
Perhaps it's time.
What do you mean?
On such a night full of stars, I'm glad to have met you.
Hey! Mister?
Long ago, nobody knew the truth of shooting stars. Pure astronomy began with observing shooting stars that filled these skies. Just as you are doing today.
Are you actually...
I couldn't say I was a scientist when you asked because I realized that there were still many things I wanted to discover. Observing meteor showers can be the key to unraveling mysteries of the solar system. I look forward to your discoveries.
Sir!